Some quick comments on electrophoresis as a purification technique. We use overly simplified electrophoresis in this course. Here's an electrode. Do not call it the cathode because you see cations, you will be in trouble. This is the one that attracts minus charge, right? Attracts minus charge. Minus charge is going to start flowing into this electron. Yeah. It's going to take electrons off of something. What do you call taking electrons off of something in chemistry? Reduction is giving electrons to something. This is the oxidation site. What letter is oxidation start with, a vowel or a consonant? With a vowel, don't say a consonant, guys. Don't worry me like that. Of the two words, reduction and oxidation, which one starts with a vowel? Oxidation. What we have the two words were cathode and anode. Which one starts with a vowel? Anode. Now, the only reason I'm bringing this up is not for this question, it's for the multiple choice question on electrophoresis. Because I either ask which species will move furthest towards the anode, or which species will move furthest towards the cathode. So for that question, you need to know anode and cathode. Here, not really important, it's just the charge of these electrodes. Well, this thing would definitely give electrons to something else, right? There's going to be reduction happening here. Where does reduction happen at? Consonant, cathode. Okay. Red cat. Cool. Tyrosine. Ladies and gentlemen, tyrosine. There's three numbers there. We know the only two that are important. I just want to remember, once you get below 10, the phenol stays phenol. What are you looking at when the phenol is as pictured on your page? You're looking at the pi molecule. How do you know you're looking at the pi molecule? 1 plus, 1 minus. I need to keep that ammonium ion protonated. At what pH must you be to keep the ammonium ion protonated? Give me the number and say above or below. 911 is the pKa of the ammonium ion. To keep it protonated, do you go below it or stay above it? Below protonates it. So I need to be below 9.11, the 9.1. You only need 1 decimal. And stay above the carboxylic acids because I want that one to lose its H as it's pictured on your page. What's the number for the carboxylic acid? And divided by 2 equals, and that's 11.3. Make that 11.4 to save yourself a little trouble. That's 5.7, right? 11.4 divided by 2. With rounding, it will be 5.7. Asp, ladies and gentlemen, the pictured molecule has a minus net charge. Which minus disappears first when you start protonating that molecule? No, the pK, she said the 2.1 protonates first. She's saying pKb 12 is better than pKb 10. No, opposite is true. pKb 10, that's 14 minus 4, people. Isn't the other pKa close to 4? Okay, I'm just saying, isn't it close to 4? Yeah, that's the better base. 14 minus 4 is 10. 14 minus 2 is 12. Pick the 10. So I need to be below the 4 and above the 2 so that one of those is minus and the other is not. Okay? Now I do want the real numbers. You said 3.9 with rounding and 2.1 with rounding, or is it 2.0? 2.1. That's the easy one. That's 6 over 2. And cis, you only have 2 numbers for cis, isn't that? No, you have the 8. Is the 8 actually relevant? Is the 8 for cysteine actually relevant? I want it to look like the one pictured on your page, don't I? How do you know that? There's nothing on the screen, people. Your cysteine. on your page right now, what charge does it have? It's got 1 minus and 1 plus. It's the one you want. Don't take that SH off. Don't go above 8. Well, now you got to get between the other two numbers, which is below 8. You can ignore the 8 now. What's the other two numbers, please? Just give them one decimal. 10.3 and the other one? 2.1? Oh, the 8 is in play. I forgot 10.3 is above 8. Let's retalk this with the actual picture here. Sorry if the picture's upside down. This is cysteine upside down, correct? Are we missing? No. And the number was 8.0 up here, or question mark? 8.0. And here they give a number, even though there's not an acid, that's 2.1. And this is the 10.3, which is the highest of all of them, the ammonium. Okay. Well, guys, if you get above 8, yeah. If you get above 8, what happens? If the S loses the proton, I'll have 2 minuses and a plus. You're not allowed to be above the 8, right? I need to keep this one on. If you're keeping that one on, the ammonium ion by default is being kept on. You don't even talk to me about the ammonium ion. If your goal is to keep the 8 on, then you don't worry about the 10.3 because it's on. Yeah, and keep off. There's your numbers, and I apologize. I didn't have the picture of the molecule in front of my eyes. I didn't know what was happening. So now I looked at the molecule because you made me. 8.0 plus 2.1 over 2. 10.1, make it 10.2. And now you got a 5.1. Tier cis, I better draw. Tier cis, H3N plus carbonyl parahydroxyl NH. I don't know why I drew the H there. NH to a group that goes to, what's this? Okay, SH, CO2 minus. There's the pick. Let's see. This is the molecule. This is the one I want. Which H is the most acidic H here because I need to keep it on. That's another way to look at it. Which H of these H's on here is the most acidic, and that one I need to keep on, and it's this. There's no 2 point, there's no, on this molecule, there is no 2. Was it 8.0? Keep on, and so I got to be below 8, and which, this one has to keep off, right? And that's the 2 point, what was it? Well, the same PI. I used the same 2 numbers, didn't I? Did I do this right? I did this right, yeah. Why am I not worried about the 10? Why is that irrelevant? If you're below 8, you're below 10 by definition already. Why is this irrelevant? This is 10.3? It's not, no, it's not the 10. Whatever, it's close to 10. Same story. I'm ignoring it for the same reason, right? So sadly, we're not going to separate cis from tier cis. Some other person will have to do that. But the real experiment does do that because this experiment only looks at one of the factors, and that's the charge factor. The other factor that they'll remind you of in biochemistry is that these chambers are filled with something, polyacrylamide gel you may have heard of, which bigger molecules move more slowly through. That will help separate them as well. We are ignoring the size factor entirely in our electrophoresis experiment. So for us, these guys aren't getting separated. Okay, I need an experiment that gets these guys spread as much as possible and I want as many moving to the left and right or as close as I can get to that. So what am I trying to say? What kind of buffer should you pick for this experiment to have as many molecules over here as you have over here? She said 4 because she wanted to get between the highest 5.7 and the lowest 3.0. She was 1 above the 3.0 and 1.7 below the 5. She could have gone like 4.2 to get a little better. 4 I would take. It's fine. Okay. 4.2 is a little more in the middle of those two numbers. As long as you give me something reasonable that doesn't crunch all of your amino acids towards one of the electrodes. That's what I'm doing here. Okay. Now, how far away from 4.2 is 5.7? That's the biggest difference. So if your pH is 4.2 and your PI is 5.7, do you start feeling like a cation or an anion? pH low puts protons onto things, and low means lower than 5.7. It's getting to be positive. Which way is it going? To the negative, and it's the one that will move the farthest because that's the furthest from 4.2. So I'm just going to say over here in this experiment, you would get a channel, like an area. You'd look at it with a blue light. You'd see this is a dark area. You'd cut it out with a knife, literally, a scalpel, and you cut it out, put it in a beaker, and wash the stuff off of the polyacrylamide gel, and then evaporate the solvent. You've got the pure tear, all by itself, purified. Now, what about the 5.1? Remember, 4.2, if you had a molecule with a PI of 4.2, it would be right smack in the middle, right? We don't have one. 5.1 is 0.9 away from that. And 5.7 was 1.5. So that was 1.5. Where's 0.9 in there? A little more than half, right? I'm thinking there. See what I'm doing here? Is this making sense? And that is the cis and cis and tear cis, because they have the same PI. And what about the 3.0? That is 1.2 away. This was 1.7. This was 0.9. So a little more than going to 0.9. This direction, this amount, a little more than that to the left. So I'm using my finger here and then stretching out to about right there. And I didn't have my pen on. Okay. So I'm going to put those boys up here, and they are called ASP. So basically, all that I needed to see is the highlighted thing here. I'm just going to highlight it. Nah, I'm going to start over. Big highlighter. Biggest highlighter you can think of. Sure. The highlighted stuff's all I need to see. I don't need the words. I just need the identities of the species and approximately where they fit in the picture. Not a terrible question, is it? No.